Today we are going to be working on algebra multiplication comparison problems, and we are going to look at what it means to compare, just like we did when we looked at them for subtraction and addition problems. So when we are comparing, we are noting the similarities and dissimilarities between two or more things, kind of like you would do if you were in reading class and you were using a Venn diagram and you would be comparing and contrasting what is alike and what is different. So we are going to do something similar but apply that to math. For our first example, we are going to write and model 18 equals 3 times 6 as a comparison in two different ways. So to do that, we are going to think back to what we did in class, and you have those examples in your math journals. And we're going to work on that problem the exact same way we did in class today. So I'm going to take 18 equals 3 times 6, and I'm going to write my statement. 18 is 3 times as many as 6. And if you remember from class today, we talked about how when we say the word is, we are going to be referring to equals, and when we say the word times, we are going to literally be referring to multiplication as in times. So 18 is 3 times as many as 6. Now we're going to take this statement and we're going to put it into a model. And so we're going to model this. So we have two rows that we need to model. We're going to have a top row and we're going to have a bottom row when we are modeling. So we're going to put down 3 boxes that on the top row, and we're going to have 1 box on the bottom row. And in each of these boxes, we're going to represent the parts. So we are going to say that for the top row, we're going to represent the 3. That's why we have 3 boxes. 3 groups of 6. 3 times 6 is 3 groups of 6. So we're going to put 6's in these boxes. So we have 3 6's here. And we're going to put a 6 in the second box on the bottom row. This box is alone. This is representing 1 part. So this shows that 18 equals 3 times 6. This 6 is by itself. These 6's represents 3 times this 6 that's by itself. And when we look at these 6's on the top row all together, that is how we are seeing that those 3 6's equals 18. And we're going to now do that again and show it in a different way. This is a comparison problem that we're going to show. So we take this exact same problem and we're going to show it as a comparison this time. 18 equals 6 times 3. Now we're saying that 18 is 6 times as many as 3. And so we represent that in a model. So on our top part of our model, we are going to have a total of 6 boxes. So it's just like saying 6 groups of 3. So we're representing this with our 6 boxes. 1, 2, 3, 4, 5, and then 6. And then we will have 1 that we will represent on our bottom to represent the second piece to our model. And inside of these, we're going to put the number 3. And all of these, we represent that with 3 because 6 times 3. So this is 6 times this 3 that's here on the bottom. And so now we have our 2 comparison problems, and we can easily see that 3 times 6 and 6 times 3, although the products are both 18, they mean 2 different things, and we can see that represented here. Now we're going to try that again. In your journal, I want you to try this problem on your own. Number 2, write and model 32 equals 4 times 8 as a comparison in 2 different ways. Make sure that you reference any of the examples that are already in your journal. Try really hard to work on showing both comparison problems as well as your statement. So go ahead and pause the video now and work on these. Okay, so let's see how you did. 32 equals 4 times 8. Our statement should say 32 is 4 times as many as 8. And we should also show that there are 4 boxes on the top with 8 in each, and then on the bottom part of our model 1 box with 8, because this is 8 alone. So this 8 should be by itself. These 8s on top shows 4 times as many as 8. And when we look at these 8s on the top all together, we can see that they equal 32. Over here, 32 is 8 times as many as 4. So we change this around to represent 8 times 4. Now we have the box on the bottom, 4. Once again, it's by itself. And the ones on top shows 8 times as many 4s than what's on the bottom. And all of these 4s represent 32, that product. And as we can see that they are not the same. 4 times 8 and 8 times 4 is not the same. Let's try some word problems. We are going to model and write an equation to solve these word problems. Daryl has 8 toy trucks. Taven has 3 times as many toy trucks as Daryl. How many toy trucks does Taven have? So within this problem, we can see how many trucks Daryl has. It tells us in the problem the number of trucks Daryl has. So we are going to set this up kind of just like we did when we were looking at addition and subtraction models. So we're going to label Daryl, and then our second part of our model is going to be for Taven. Daryl's part is 8, so we know that he has 8 trucks. So his part of the model is just going to represent those 8 toy trucks. Now we need to look at what Taven has, and he has 3 times as many as Daryl. So he's going to have 3 boxes to represent the 3 times as many trucks as Daryl. And how many does Daryl have? Daryl has 8. So that lets us know that Taven has 3 times as many as 8. So we put 8s down here to model his part. And then we are now going to be able to figure out an equation. We're going to use a variable n, and like we talked about in class, a variable represents the unknown. Since we do not know how many Taven has at this point, then we are going to have to figure that out. So now we need to create a multiplication equation. So our equation is going to be 3 times 8. This is what our equation should look like. We have to be careful that we're not thinking that it should be 8 times 3, because that is not representing this model that we just drew. Now we can solve for this equation. N equals 24. 3 times 8 is 24. And if we add these all up, all these 8s for Taven, we can figure out how many he has. And now we can answer that question that Taven has 8 toy trucks. Not 8, 24. Taven has 24 toy trucks, not 8. Let me fix that. Not 8, 24 toy trucks. Okay, he has 3 times as many. Each part represents 8, but he has a total of 24 toy trucks. Let's try another one. Miss Cassidy has 3 times as many rabbits as Mrs. Clemens. Miss Cassidy has 6 rabbits. How many rabbits does Mrs. Clemens have? This problem is a little bit different than the one that we just did above. This is a different comparison problem. We are going to go ahead and represent the 2 people that are in the problem. So we have Miss Cassidy, so she's going to have a part of the model, and then we have Mrs. Clemens, who is also going to have a part of the model. Now, for Miss Cassidy up here, we know that she has 3 times as many rabbits as Miss Clemens, and Miss Cassidy has 6. So she has to have 3 parts because she has 3 times as many as Mrs. Clemens. So for her 3 parts, we're going to go ahead and use a variable because we know that all of these together is going to be 6, because this tells us that Miss Cassidy has 6 rabbits. And we have to figure out how many rabbits Miss Clemens has. So Mrs. Clemens is going to get 1 of the parts, as we do not know how many she has. We just know that Mrs. Clemens has that Miss Cassidy has 3 times as many as Miss Clemens. So since we know this part for Miss Cassidy, we could go ahead and represent the 3 times as many. And we also know that this 3 times as many is equivalent to 6. So this part from Miss Cassidy is going to equal 6. Now we have to figure out what our equation is going to be. Since we know that Miss Cassidy has 6 rabbits, okay, and we know that that is 3 times the amount that Mrs. Clemens has, and we just don't know Mrs. Clemens' part yet, this is what our equation would look like. 6 equals 3 times n, or 6 is 3 times as many as n. So this is what this statement is saying. Now we need to figure out the parts and how would these parts be equivalent to 6. Well, I know that I need to come up with a number that when I multiply it by 3, I'm going to get 6. And that number is going to be 2. When I look at this, I can tell that if I put in the number 2 for each of these parts for Miss Cassidy, I indeed would get 6. So that part checks off. Now I can answer the question. Mrs. Clemens has, to answer this question, 2 rabbits. Now I want you to try some more of these on your own in your journal. And you need to make sure that you reference any of these examples, particularly these 2 problems, because they are set up differently. So you have one comparison word problem that looks like this, where we know the unknown part for Daryl, and we went ahead and plugged that in, and then Taven's parts were here. So we can see that it's kind of opposite of what we have on the bottom, where all of these parts unknown represented Miss Cassidy's, and then we did not know what Mrs. Clemens was, and that her one part was on the bottom as opposed to the top. So we need to make sure that we're representing these problems accurately. Now I would like for you to try 5 and 6 in your journals on your own. We will discuss these 2 problems in math. They are very similar to 3 and 4 on the previous page, so if you need to rewind or check your journal to go back and look at those, please do so. Remember to complete your whisk in your journal, and on Edmodo, don't forget to leave me a note that says you have watched the video. See you all in class tomorrow.